Hello, I hope you are having a good day. I'm the Amateur Logician from amateurlogician.com, and today we're going to talk a little bit about the traits of arguments. Or I should say at least deductive arguments. Now, logic helps us think about the general forms, structures, or patterns of argumentation. We can think about arguments in the abstract. Just like we can think about mathematical equations, so to speak, in the abstract, we can also think about arguments in the abstract. For example, we can think about even numbers in terms of an equation. We can think about even numbers in the abstract. We can also think about arguments in the abstract. So let's think about some traits of arguments. First up, we have to think about validity. An argument is valid if and only if, where we abbreviate if and only if as IFF, the premises entail the conclusion. And that's it. This doesn't mean that the conclusion is necessarily true. In fact, it might actually be false. A valid argument only means that the premises entail the conclusion, such that if you deny the conclusion, there's a sense in which you would be contradicting the premises. Logic helps us think about what it means for an argument to be valid. For instance, certain general forms, structures, or patterns of argumentation are valid, and some are not. That is, they're invalid. We can also think about soundness versus unsoundness. So we have a sound argument when, one, it's valid, the argument's valid, and two, all premises are true. With a sound argument, we're guaranteed a true conclusion. So logic helps us extend our knowledge. It does so when we already have some premises we know are true. We can then apply the tools of logic to validly derive new things, to validly derive a true conclusion based on true premises. Now I want to illustrate something, actually with the language of propositional logic, before I talk about these other notes. So let's say we have the first premise, P and G arrow T. So this represents all true premises, P for premises, and a valid argument. And here I'm just using the letter G for that. Then we get a true conclusion. But let's say for the second premise, we're saying we're not getting a true conclusion. We know the conclusion is false. So because of that, we're denying the consequent, so we can deny the antecedent in that conditional first premise. So we can then say, therefore, it is not the case that P and G by modus tollens with lines 1 and 2. In other words, we cannot have all true premises in a valid argument, but that's the same thing as saying that either we have premises that are false or we don't have a valid argument. So that would just be using De Morgan's rule on line 3. So either the premises are not all true or the argument is not valid, or both of them. That is to say, we don't have all true premises and the argument is not valid. So with that said, let's think about different situations. So for example, the first situation is where we have all true premises. We have a valid argument. Well, then we're guaranteed a true conclusion. In other words, this first possibility just represents a sound argument. True premises plus a valid argument guarantees a true conclusion. On the other hand, let's say we have all true premises, but we have an invalid argument. Well, then the truth value of the conclusion is simply unknown. It might be true or it might be false. For example, if I argue all men are mortal, Socrates is a man, therefore grass is green, Well, we do have true premises. The conclusion is true, but the argument is invalid because grass is green has nothing to do with all men being mortal or Socrates being a man. Or we might say, all men are mortal, Socrates is a man, therefore grass is blue. Here we have all true premises, we have a false conclusion, we have an invalid argument. Next, consider having all false premises in our argument. Well, in that case, the conclusion is also unknown. It may be true, it may be false. The argument might be valid or invalid. It doesn't matter. In this case, the conclusion's truth value is simply unknown. For example, let's say I argue all circles are squares, grass is blue, therefore such and such. That conclusion's truth value is going to be completely unknown if the argument is valid or invalid, because we just have all false premises. Now, we can go both ways. So on the one hand, we can think about this in terms of starting with the conclusion, knowing its truth value, and then think about, well, what does that mean about the premises given that the argument is valid or invalid? Or we can just think about the premises being true or false, and then knowing if the argument is valid or invalid to then determine the truth value of the conclusion. Well, in fact, we've already done that. So if we have true premises, a valid argument, then the conclusion is guaranteed to be true. But in all other cases, the conclusion's truth value is just going to be unknown. So if we have true premises, invalid argument, the conclusion might be true, it might be false. We don't know. But here, let's think about this way. Let's say we know we have a true conclusion. We know the argument is valid. What does it follow about the premises? Will the premises be true? Will they be false? Well, in fact, their truth value is unknown. But we do know that if we have a false conclusion and the argument is valid, then at least one premise must be false. We know that for a fact. If we have a true conclusion, an invalid argument, the premises are unknown in their truth value. If we have a false conclusion, an invalid argument, again, the premises are unknown in their truth value. So this is just a basic introduction to some traits of arguments. And I hope this video has been helpful and useful to you. I am the Amateur Logician from amateurlogician.com. And if you enjoy this type of material, consider visiting my website at amateurlogician.com. You can subscribe to my newsletter. Bye for now, and be well.